Good morning, students. So we'll move on to the next topic, that is sensor networks. So in previous lecture, we were discussing about what should be called as the things in case of IoT. Okay, so what are the different components are involved in case of smart objects? The components were the sensors, different varieties of sensors we discussed regarding different classifications also we discussed. Then later, we discussed regarding how the actuators will be working, what is the work principle of actuator, fine. Then later we discuss something about the smart objects also. Now, after discussing about the things, we need to discuss about the sensor networks. Okay, so here we are using a network name called as SANET. Okay, so the full form of SANET is what? Sensor or actuator network. Okay, sensor or actuator network. As the name suggests, is a network of sensors that sense and measure their environment and or actuators that act on their environment. Okay, so this is what this like network we are deploying, we are creating, okay, which will allow the sensor and actuator to exchange the information. Like it may be like or what we are calling, like it may be the information sent by the application layer, or it may be the action taken by the sensor or action taken by the actuator. Okay, so if we want to work properly, then we need to establish a network between the gateway and the sensor, okay, using which both the sensor and actuator will be working properly. So here what we are expecting is effective, well-coordinated communication and cooperation is a prominent challenge. So here we are expecting a well-coordinated network between the gateway and the sensor or the actuator. That is what the very important challenge we are facing. So we'll see that, okay, how we can deploy, or how we can prepare, or how we can create a network, okay, which should be suitable for the IoT architecture. So in this session, we'll be discussing some limitation and we'll be discussing some advantage of using the SANET. Okay. Then later, we need to go for a proper kind of sensor network with advanced protocols and all. Okay, so that our IoT network should be suitable for each and every condition. It is not like, okay, it is suitable for only measuring the temperature. Like the same protocol should be used for measuring the pressure or any for any other purpose. Such type of protocol we need to design. So we'll go through, okay, whatever the challenges we are facing over here, or what are the limitations we are having, okay, how we can resolve it, we'll discuss. Okay, SANET offer highly coordinated sensing and actuating capabilities. Okay, smart home are a type of SANET that display this coordination between distributed sensor and the actuators. So the like smart home, okay, means for operating the doors or for operating the electric gadgets, okay, or for electric equipments, whatever, like AC, TV or fan, okay, such type. So here, and for controlling the like light, okay, occupation sensor may be used over there, okay, for controlling the lights, okay. So smart ceiling and all, or else regarding the Wi-Fi, it may be, regarding the security, it may be, okay. So those are all comes under smart home network exactly. So there also we are deploying the sensor and the actuator. Sensor for sensing the information, actuator to take some action exactly. So that is what we are calling it as a SANET. Okay, there is a network established locally for providing or for allowing the sensor and actuator to communicate. Okay, then later, while such network can theoretically be connected in a wired or wireless fashion, the fact that SANET are typically found in the real world means that they need an extreme level of deployment flexibility. So here, what we can notice over here is what deployment flexibility should be more. Okay, so that is what the main requirement we are observing over here, because like it should be fitted for all varieties of constraint. Okay, that's why we are calling it as, okay, flexibility over here. Okay, high end flexibility we are expecting. The following are some advantages and disadvantages that a wireless based solution offers. Okay, so in previous slide, the last point we discussed, like, okay, it may be wired or wireless. Okay, the only thing is flexibility we need to achieve. But when we are comparing wired with wireless, the flexibility can be achieved using wireless itself. Sorry. Okay, so now we'll see what are the advantages we can achieve and what are the disadvantages we are facing in case of wireless based solution for this kind of scenario. Okay, greater deployment flexibility. So this is the best advantage of going for wireless network. Okay, so especially in extreme environment or hard to reach places. Okay, so sometimes, example like if you are trying to measure the temperature of particular machine or particular any manufacturing unit and all. So like every time in case of repairing and all, if you are placing a wireless based sensors and all, then we need to maintain those wire because there is a extreme heat condition over there because of the environment condition. Okay, we may not reach it properly. Okay, so better to deploy like a wireless based sensor over there, then we'll be getting the flexibility over there. Fine. Then simpler scaling to a large number of nodes. Okay, so we can in upcoming topics you'll be getting to know like okay the sensor introduction or involving the sensor to a network will be very simple. So any number of sensor can be deployed over there with less effort for introducing it to the network. Okay. Then later, low implementation cost, then easier long-term maintenance. Okay, wireless will be better, like not like maintenance cost will be very less. The best example, we are using our mobile phones. Is it right? So, what is the connectivity we are having? Wireless-based connectivity we are having. Base station to mobile devices exactly. But previous days, when we were using, I don't think like we are very familiar with the landline phones and all because we are the young generation. Okay, but when we were like kids and all, then we used to addicted for the landline phones. Is it right? Like if you want to call, then it should be wire-based communication itself. So if there is a lightning or if there is a heavy rainfall, then it will be having some disturbance. Okay, in case of wire-based communication. Okay, so like maintenance. Okay, but in case of our mobile networks and all, okay, such type of if there is a lightning, whatever it may be a thunderstorm also doesn't matter exactly, right? Okay, so that is what we are calling it a long-term maintenance. Okay, easier long-term maintenance. If you go for a wireless, that will be maintenance free exactly. Okay, then effortless introduction of new sensor or the actuator. So this is what I was discussing about. Okay, like simple scaling to a large number of nodes. Okay, so here like any number of devices can be adopted. Okay, no problem. And if you want to provide it for the working environment, then the like introduction is very simple. See how we are using USB ports, right? Okay, if I want to connect the mouse, I can connect it from like USB port. For the same port, if I want, I can connect the keyboard also, printer also, scanner also. Is it right? And dongles also, if I want. Okay, like wireless dongles, if I want, that can be connected. Okay, like introduction is very simple, like just plug and play such type. So here also we need to deploy the sensor for that network. Okay, so who are all coming under that range, authentication procedure will be available. Okay, but it will be simple exactly. Okay, then better equipped to handle dynamic or rapid topology changes. Okay, so here sometimes we need to change the topology obviously. Okay, whenever we are facing some range problem and all, we used to deploy the radios and all, right? Okay, so when you will be facing the network issues in case of a mobile, what they will be placing the base station or a base server. Okay, so that will resolve the network issues and all. Okay, so these are the bit advantages. Okay, when we are going for wireless based solution for these kind of a network. The disadvantage is what potentially less secure. Okay, the devices, the network devices, routers and all, which should be exposed for the environment. Okay, so hijack access point that threat is available. Then typically lower transmission speed that is also available because number of devices are more, so the bandwidth available for transmission will be less exactly because it will be shared among each and every users or each and every sensors over there. Greater level of impact or influence by environment. Okay, so here sometimes due to some noise, we are calling it as disturbance. Okay, we may have impact from the environment. Okay, so these are the few disadvantages, but we have a lot of advantages compared to these disadvantages. So these characteristics are the key reason that wireless SONET is the best network technology for IoT. Okay, so we'll see that wireless sensor network. Okay, so we'll be discussing about this wireless sensor network, or else wireless SONET we are calling it as. Wireless sensor network are made up of wirelessly connected smart objects, which are sometimes referred to as modes. We are also calling it as a modes. Okay, then the fact that there is no infrastructure to consider with the WSN is surely a powerful advantage for flexible deployments. But there are a variety of design constraints to consider, okay, with these wireless connected smart objects. So here they just mentioned like some constraint, okay, what we can face in wireless sensor networks. The first one is power consumption is critical because we'll be deploying it for many number of devices. So handling those devices will consume a lot of power. So power consumption will be critical. Okay, moderate CPU power, the computation power will be less. Low memory, availability of memory for operating system and the other tasks will be less. Okay, then lossy communication. So we cannot trust the network. Okay, like we may lose some packets over here. Then narrow band media. Okay, so for communication we are having maximum of 250 kb. Okay, means it could be a narrow kind of connectivity we are having. Okay, so we'll see that. Okay, how we can overcome. So we are discussing about some limitations. Okay, of this wireless sensor network. Okay, so how we can tolerate it or how we can resolve it, we'll see that. Okay, how it can be done. The following are some of the most significant limitations of the smart objects in wireless sensor network. Limited processing power. So this is the first thing. Second is limited memory, lossy communication, limited transmission speed, and limited power consumption. Okay, so the power availability exactly. So these are the few limitations what we are facing in our wireless sensor network availability. Okay, available wireless sensor network is having such type of a problem, but if you are involving certain strategy, so involving some kind of a protocol, okay, we can resolve few of these limitations. Exactly. We'll see that how we can do it. Because of these limitations, number of sensors deployed in environment is low. Okay, so here the like transmission speed it may be, or else the accuracy what we can expect from this network will be less. So what we do, we'll be deploying many number of sensors. Exactly. See, if you are unable to trust on one person, so what we will do, we will provide many number of person over there. Okay, so from them whatever the inputs we are getting, from that we go for aggregation, we call it as. See, one job we are having, one class, okay, with one lecture, okay, or one professor. Okay, if principal is not feeling like no, he cannot manage that class properly, then what he will do, he may send four lectures today, okay, for presenting this session. Okay, then later like after aggregating it, it will be provided for students, such type. Okay, so here deploying the, when we don't have a confidence on the network, what we do, we will be going for many number of devices over there, and WSN will allow the data aggregation among these sensors deployed for the same reason. Okay, for same reason, if you are deploying, if you are unable to achieve the accuracy, what you do, you will be deploying many number of devices over there. So all will be having their own output, right? So that output should be aggregated so that we can get a proper result. Efficiency, if you want to, or accuracy, if you want to achieve, then you need to go for aggregation. Okay. Then example of such a data aggregation function is in a WSN, where temperature reading from a logical grouping of temperature sensors are aggregated as an average temperature reading. So in next slide, we have a figure. Okay, figure number 3.9. There we can identify such type of condition. Okay, see, for one particular area, if you want to measure the temperature, what is the temperature available? So what we are doing is we will be deploying the wireless sensor network, obviously. Okay, along with that, what we do, we deploy many number of sensors for measuring the temperature. Temperature sensor will be deployed over there, many number of temperature sensors. Then whatever the information we are grabbing it from the sensors, right? Okay, overall we take the aggregate, means the total temperature, whatever we are getting, divided by the number of the sensors deployed. Example, like if it is the total temperature, average temperature is like 100. Okay, so 10 devices if you are deploying, 10 sensors if you are deploying, divided by 3, then you'll be getting the aggregate. Means the original temperature available over is 10 degrees Celsius, such time. So these data aggregation techniques are helpful in reducing the amount of overall traffic and the energy. Okay, in WSN, okay, with very large number of deployment smart objects. Okay, so This we can call it as a drawback also, and we can call it as an advantage also. Okay, for accuracy, we deploy many number of devices, but the traffic we are generating is more exactly. But with the application of this data aggregation, we can reduce. See, 10 different lines you are having, 10 different inputs you are getting. Out of that 10, you are aggregating it to one, right? Then the traffic 10 into one conversion it will be. Then the traffic will be reduced. This data aggregation at the network edge is where fog and mixed computation is available. So this procedure will be involved in the either gateway level or in the smart object level pixels. Okay, so this is the example of data aggregation I was explaining. Okay, so here we are deploying 1, 2, 3, 4, and 5. Okay, so 6 sensors are available exactly, total 6 different sensors. Okay, so here, see each and every sensor is sensing the temperature in the different corners exactly. See 6 corners we are having, 6 sensors we are placing. So each is having like 7.1, 12.2, 11.3, then 10.8, such stuff. Okay, then what we do, we will be merging this all temperature and we will be coming for the aggregation. Okay, it should be divided by 6 and you'll be generating 11.7 degrees Celsius. So this 11.7 degree will be transferred to the gateway exactly. Then see here, 6 load or 6 input we are getting. Okay, for this point, from this point we are generating only one. Okay, this process we call it as a data aggregation. Then wireless connected sensor or smart object generally have one of the following two communication patterns. Now we'll see on what fashion your communication device, or like on what fashion your sensor or the actuator used to communicate exactly. That is very essential because you should know, okay, what type of information you are getting and what traffic you are getting. Regarding this, everything we should have information. Then event driven or periodic we call it. What is this event driven? See, we have explanation. Transmission of sensory information is triggered only when a smart object detects a particular event or predetermined threshold. See, whenever such situation occur, whenever that threshold value has been reached, then only the information will be transferred to the gateway. Okay, then we call it as event driven. Okay, means your temperature sensor will be always sensing the temperature. If it exceeds 15 degrees Celsius, then only it should be intimated to the gateway exactly, because if it exceeds 17 degrees Celsius, it may melt something. Okay, so when we have a threshold point reached up to 15 degrees Celsius, then itself we need to communicate it with the gateway. So this we are calling it as event based. If anything happens, then it should be intimated. Otherwise, no. Okay, then periodic means what? Transmission of sensory information occur only at periodic intervals. Means duration based we call it. For every half an hour or for every hour or particular day or for a day, okay, such type. Okay, it will be having some time limits over there. Okay, based on that, it will be communicated. Okay, such type of facilities also available. Additional advantages of being able to deploy large number of wireless low-cost sensors are the inherent ability to provide fault tolerance, reliability, and the capability to extend the life of a WSN, okay, especially in scenarios where the smart objects have limited battery life. Okay, so these are the few advantages if you go for deploying low-cost multiple sensors. Okay, then autonomous techniques such as self-healing, self-protection, self-optimization are often employed to perform these functionalities on behalf of an overall WSN network. Okay, so these are the few advantages and autonomous techniques we can deploy for wireless sensor. Okay, fine, let it be. Then we'll go for the next topic, communication protocol for wireless sensor network. So under this, we'll be discussing lots of communication varieties and protocols. Okay, but before that, what limitation we have, we'll discuss that. There are literally thousands of different types of sensors and actuators. To further complicate matters, okay, WSN are becoming increasingly heterogeneous with more sophisticated interaction. So previously, the IoT network was homogeneous, means similar type of sensors we used to use. Okay, but now we have a conversion like from homogeneous to heterogeneous. Sometimes we will be having a two different like homogeneous and heterogeneous. There will be a communication between these two network also. Such type of possibilities also available. Then WSN are seeing transition from homogeneous wireless network made up of mostly a single type of sensor to network made up of multiple types of sensors that can be even be a hybridized mix of many cheap sensors with a few expensive ones used for very specific high precision functions. So wherever you are expecting a particular kind of information, they will be going for a cheap, like costliest sensors. Okay, rest of the places where you feel that it is not most essential or most necessary or most important, then we can go for cheaper kind of sensors. Such type is available exactly. Like it all depends on the network administrator or the organization, like how they want to deploy the IoT network, on what fashion it should be, what should be the investment cost regarding that. Okay, everything will be depends on the organization exactly. So we cannot restrict the organization like no, you cannot do such stuff, right? Okay, it's his opinion, like whether he want to go for cheaper version, whether he want to go for a costly version of sensors, depends on him exactly, right? But what you need to do is, we need to design a network architecture, we need to design a protocol which should handle this type of a situation. Then coordinated communication with sophisticated interaction by constrained devices within such a heterogeneous environment is called a challenge. Okay, so we'll see that how we can resolve on that. Any communication protocol must be able to scale to a large number of nodes. It should handle large number of nodes, requirements of a specific application. Okay, power consumption, maximum transmission speed, range tolerance for a packet loss, then tolerance for a packet loss, sorry, then topology, optimization, security, and so on. So these are the very basic requirements, security and quality of the service. Okay, then topology supported and all. Okay, so these are the basic requirement of any kind of a protocol if you are designing. So these are the like concepts we need to keep in our mind. Okay, when we are selecting the protocol or when we are designing the protocol. Communication protocol needs to facilitate routing and message handling, data flow between sensor node as well as from sensor node to optimal gateway to edge computing or centralized cloud computing. So these are the aspects which should be handled by our communication protocol. So these are very basic. Okay, it's must and should. Okay, IoT is one of those very technologies. Okay, that impacts all varieties and industries. Okay, which means standardization of communication protocol in a complicated task. Okay, then later requiring protocol definition across multiple layers of stack as well as a great deal of coordination across multiple standards deployment organization. So these were the few limitations and the concepts we need to concentrate when we are trying to design any sensor networks. Okay, so in future classes we'll be discussing how to connect, okay, the smart sensor network. Okay, so regarding that we'll be discussing. Then how we mentioned like SANET and all such type of we are having lots of network availability over there. So what are the different networks we'll be facing? Then what is the protocol we need to use? Different kinds of protocol we'll be using, different kind of standards we'll be using, IEEE standards and all. We'll be discussing regarding that. So this is for our students. So we'll meet with next session in next lecture. Thank you, students.